Hello there, welcome to AP Calculus Lecture 5.1a. We're talking about the number e and natural logs. We'll be working some example problems from page 318 today, so you may want to go ahead and turn to that. And everything today you should have learned in Algebra 2 or Pre-Cal or both. If you had me for those classes, then you learned them. We went over this in both classes. But we're going to talk about the number e and natural logs and properties of logs so that you can use those to perform calculus operations on them. So first of all, let's start with the number e. So let's graph y equals e to the x. So I'm gonna mark the point 0, 1 here. So x equals 0, y equals 1. And y equals e to the x looks something like this. So you can graph that on your calculator if you want. And where that number e comes from is that where it crosses the y-axis, the slope of the tangent line at that point is equal to 1. All right, what I drew was a little shallower than 1, but just pretend I drew it at a 45-degree angle there. All right, its inverse function, and it crosses the x-axis at 1. So we'll label this a point 1, 0, is y is equal to the natural log of x. Okay, so let's write a few facts about e and the natural log. So e is approximately equal to 2.71821. So it goes on forever. Y equals e to the x has a slope of 1 at the point 0, 1. E is very important extra ant there, didn't I? Very important in modeling things that occur or let's say processes in the natural world. And such as population growth, or radioactive decay. We did both of those in pre-cal. All right, e to the x and the natural log of x are inverses. And the natural log is just equal to log base e. All right, it's a log function, but base e. All right. So let's talk about logs for a second. So these are the exact words I used if you had me in pre-cal class. A log is an exponent. All right, so if we have log base b of a is equal to c, what we're saying there is c is the exponent that you must raise b to get a. So b stands for the base, c is the exponent. So if we were to rewrite this as an exponential equation instead of a logarithm, it would be b to the c power is equal to a. So I always look at it like this. I just kind of have a pattern in my sight line. B to the c equals a. B to the c equals a. Kind of do it like that. So here's some examples. So let's evaluate log base 2 of 8. So that's the same thing as 2. Now we're going to use x as what we're solving for, our exponent. 2 to the x power is equal to 8. All right, so x is equal to what? Hopefully you don't need a calculator for that, but x is equal to 3. So evaluating the log base 2 of 8, the answer is 3. Okay, and you could use any variable here. You could use, a question mark. Let's say we have log base 2 of 1/4. So that's like saying 2 to some power is equal to 1/4. Well, can you do that? Try that in your head and tell me what it is. Or tell the computer screen or your phone what it is. All right, it's going to be -2. Okay, so we think about that a little bit. 2 to the -2 power is the same thing as 1/2 squared, which is 1/4. So you have to kind of put your brain in the negative exponent process there for a second. All right, how about log base 2 of 2? That's like saying 2 to some power, x is equal to 2. So x would be what? It would be 1, not 0. Have students, they get the whole 0 and 1 thing backwards sometimes. But we'll go ahead and do one like that. Let's say we have log base 2 of 1. So that's like 2 to the x power is equal to 1. Now that's 0. Anything to the 0 power is equal to 1. And those things that's students forget those every year. All right, but once you get back to it, using it all the time, then it's easy. All right, let's talk about the properties of logarithms. Okay, first of all, if we have log to the base b of some product, let's say it's a times c, that's equal to log base b of a plus log base b of c. So the log of a product, and I won't write this every time, but the log of a product equals the sum of the logs. All right, let's say we have log base b of a divided by c. So we have a fraction here. All right, that's equal to the log base b of a minus the log base b of c. So the log, I won't write this down every time, but the log of a quotient is equal to the subtraction of the logs. All right, how about log base b of a to the c power? Now this is one we used a ton in pre-calc or and algebra 2. So I wonder if you can remember what do you do with the c there? Well, the c comes out front, so that's the same as c. The c just becomes a coefficient, log base b of a. All right, that's one you will use a ton. So you bring that c out front. All right, if you see log with no base, it just says log a or something like that, no base written. Do you remember what that means? So you have a button on that for your calculator. That just means log base 10 of a. No base written means base 10. All right, log base e of a is the natural log of a. So let's do or talk about some of the properties with the natural log. So if you have natural log of e is equal to 1. All right, that's just worth memorizing, but it's like saying e, that's the same as saying, this is what I want you to memorize here, but that's like saying log base e of e. Right, so e to the first power is equal to e. But definitely one worth remembering there. So if you have the natural log of e to the x, that's the same. We can bring that x out front as x natural log e, and that's just 1. So if you have natural log e to the x, that's the same as x. If you have e to the natural log of x, that's also just equal to x. The e and the natural log, they're inverses, they cancel each other out. Okay, so whatever you would have, if it's e to the natural log of 7 is just going to be 7. Okay, so e to the natural log of x is equal to x. And finally, the last property to remember is the natural log of 1 is equal to 0. Because that's like saying e to the 0 is equal to 1. All right, so let's look at our textbook. We're going to do a few examples here. All right, we are on page 318, and I'm going to start with number 16 here. So it says, use the properties of logarithms to write the expression as a sum, difference, and or multiple of logarithms. All right, so Example 16. And all of our examples today will be on page 318. So you have the natural log of 1/5. Well, that's a quotient, so that's the same as the natural log of 1 minus the natural log of 5. The natural log of 1 is equal to 0, right? So that's the same as 0 minus the natural log of 5, which would be negative the natural log of 5. All right, example 18. We've got the natural log of this product, x, y, z. So the natural log of product is just the sum of those natural logs. So that's the natural log of x plus the natural log of y plus the natural log of z. And that's all you have to do. There's really nothing else on that problem to do. All right, example 20. We have the natural log of the square root of a minus 1. Well, let's write that as a minus 1 to the 1/2 power. Well, what can I do with that 1/2 now? Well, I can bring that out front as a coefficient. So that's 1/2 natural log of a minus 1. Now you can't break up that. That's not a product or a quotient. It's just a minus 1. So we can't break that up anymore. This is the best we can do. All right, example 22. We have the natural log of 3e squared. Well, this is a product first and foremost, and then we have an exponent. So let's break up the product into the natural log of 3 plus the natural log of e squared. So that's going to be the natural log of 3. That's just a decimal number. You can put it in your calculator. And then we'll take this 2 and bring it out front. 2 times the natural log of e. Well, the natural log of e is just 1, right? So this is the natural log of 3 plus 2. All right, pretty cool. So hopefully this is bringing back memories from both Algebra 2 and Pre-Cal of you doing problems like this. So we have the natural log of 1 over e. Okay, that's going to be a difference. If it's a quotient, we can turn it into a difference. So that's the natural log of 1 minus the natural log of e. We know that the natural log of 1 is 0, and the natural log of e is 1. So that's just a fancy way of saying negative 1, isn't it? All right, pretty cool. Okay, let's take a look at number 26. I think I can put this in here without having to erase. So 26, we have 3 natural log of x. Now this time we have multiple logarithms. We want to combine them into a single log. Plus 2 natural log y minus 4 natural log z. Okay, we've got addition for the first, but the first thing you want to do is take care of these coefficients. So let's take care of those now and make them into exponents. So that's natural log of x cubed plus natural log of y squared minus natural log of z to the 4th. Now we have a sum here, so we can say that's natural log of x cubed times y squared minus natural log of z to the 4th. So what you do is just go left to right. Let's do our combination from left to right. So first we have a plus. Now we have just 2 terms, and we have a minus. So that means we're going to bring that z to the 4th underneath. So this is the natural log of x cubed y squared divided by z to the fourth. And it's probably best to put parentheses around all that so you know you're taking the natural log of that entire fraction there. All right, remember, just go left to right. Combine with multiplication and then subtraction after you do the multiplication. If we'd have a minus first, then we would have brought y squared underneath. And then if we had a plus second, we would have multiplied. Okay, left to right. My cat is desperate to get in and just banging on the door like crazy. Don't know if that's coming through on the video, but that's what that is. All right, one more, and then I'll give you the homework assignment. So let's do number 28. We're going to combine number 28 into a single logarithm. So we've got 2. And we have the natural log of x minus the natural log of x plus 1 minus the natural log of x minus 1. Okay, let's worry about the 2. We're going to deal with that at the very, very end. But we have subtraction here. So this is the same as, we've got this 2 out front, natural log of x over x plus 1 over x minus 1. So it's the natural log of all that. And we still have the 2 out front. What you do, this is the same as x over x plus 1 times 1 over x minus 1. So we can bring, so you can't leave the fraction as, a triple there. We've got to bring this bottom term up a level. So this is the same as 2 times the natural log of x over x plus 1 times x minus 1. Okay, and then our last thing to do is to take that coefficient 2 and bring it out here as an exponent. So finally we have the natural log of x over x plus 1 times x minus 1 all squared. All right, and that is how you combine all of this into one fraction. If this had been plus, then it would have ended up on the top. Okay, so, but this time they're all minuses, so I went ahead and made it a kind of a compound fraction there and then brought it up into a regular fraction. Okay, your homework, none of it is calculus, is it? We'll get back to that tomorrow. It's on page 318. And you just have to do 15 through 29 odd. And all the answers are in the back of the book. So that'll remind you how to break up these log functions and how to combine them. And then on the next lecture, we'll talk about how to do the calculus on logarithmic functions and base E functions. All right, that does it. Talk to you next one.